Okay, so what do we have hope here for? Well, number one, I see 1 over something. Okay, so when I see 1 over something, I'm going to go for log. But for that, I need to see the derivative of that something in the numerator. And the derivative of this something is e to the x. And in the numerator, I have that squared, essentially. So that doesn't work. No log here. Okay, if it were e to the x, beautiful log. Because it's e to the 2x, no log. So next, I'm going to the splitting trick, where the unsimplifying step, where I assume that somebody took the derivative of a very simple function, and then they simplified it at the end, and that simplification step hid the structure that I'm trying to look for. So now I will look for ways to unsimplify the expression and see if something occurs to me. So here, I can split e to the 2x by the product rule of exponents as e to the x times e to the x. And does that help? Well, yes, it does help, because e to the x is the derivative of e to the x. So I'm going to do this in one step. I recognize that one of these e to the x's is the derivative of e to the x. So it's going to go right under the differentiation sign. You guys are with me on that? Yep. So I'm going to write this. So once again, I realize there's an extra step, or actually, we're going to use what we learned in the previous example. So I'll save myself some trouble by making this the antiderivative. So now if this is u, then this is u in the denominator, and very simply u minus 1 in the numerator. So u minus log natural of u. And now I'm remembering that e to the x plus 1 was u. So this becomes e to the x plus 1. And once again, I'll let the constant of integration absorb the plus 1. So we're just left with minus log of e to the x plus 1. And, just for documentation purposes, this is where the plus 1 went. Absorbed into C. And that's example number 2.